All right, so problem 5, we got a random sample of 100 likely voters in a small city produced 59 voters in favor of candidate A. The observed value of the test statistic for testing the null hypothesis HO is that P equals 0.5. So the proportion, population proportion is 0.5 versus the alternative hypothesis, where the population proportion is more than 0.5. Okay, so we just got to basically make sure we know what values are supposed to go into, our formula for our test statistic, and that's not a problem, remember, because we know our test statistic will be Z. Remember the ZAP tax, like an acronym. So when we're talking about proportions, we're going to use a Z test. Means T test. So ZAP, the Z, is going to be our sample proportion P hat minus our null proportion hypothesis P naught over the standard deviation of the distribution if we assume that the null hypothesis proportion is true, which is what this is by definition. So we have P naught times 1 minus P naught over N. So what they, I believe, are trying to test you on is to make sure that you know that it's P naught in the standard deviation formula and not P hat. That's usually a common mistake made, like when you're making the confidence interval for the sample proportion. So P naught is probably what, I assume that's what they're trying to get at. So our Z would be P hat, would be 59 over 100, 0.59 minus 0.5 over, let me zoom in a little bit. The square root, P naught will be 0.5 times 1 minus 0.5, so 0.5 times 0.5 over 100. So let's see what we got. So our answer will be B. All right. Number 6. The researcher claims to have found a drug that causes people to grow taller. Wow, it's quite a drug. Let's continue. The coach of the basketball team at Brandon University has expressed interest but demands evidence. Over 1,000 Brandon students volunteered to participate in an experiment to test this new drug. 50 of the volunteers are randomly selected, their heights are measured, and they are given the drug. 2 weeks later, their heights are measured again. The power of the test to detect an average increase in height of 1 inch could be increased by, I wonder if this really was a study. This is a pretty crazy experiment. I don't know who would, I wouldn't volunteer, but anyways, let's move on to the problem. So, okay, so we're talking about power, the power of the test. So remember, the power of the test, it's kind of just, don't overcomplicate, just kind of go on your intuition. Like to increase the power of the test, like any study, you want more data. You always want more data. Like more information is better. That's always one thing. And then the other thing you want to be able to remember is that since your alpha level is the probability that you're going to reject the null hypothesis when the alternative is true, you want to increase your probability of rejecting the null hypothesis. So that if you increase your alpha level, to anything more, if you just increase it in general, that would increase your power. So increase alpha, increase sample size. So let's see what we got here. Using only volunteers from the basketball team. Nope, not that. Using 0.01, nope. We don't want that smaller. That's the opposite we want to do. C, using alpha equals 0.05 instead of 0.01, that's going to help. Let's see what the other ones would be. Giving the drug to 25 randomly selected, and that's the opposite. That's a smaller sample size. Using a two-sided test instead of, nope. Those are all incorrect. So the answer is C. All right. Now, number 7. A 95% confidence interval for a population mean mu is calculated to be 1.7 to 3.5. Assume the conditions for performing inference are met. What conclusion can we draw for a test of HO? Our population mean equals 2 versus HA, not HI, I mean ha, HA. Alternative hypothesis, mu is not equal to 2. That's alpha equals 0.05. So we got this confidence interval, and our null hypothesis is that, the true mean is 2. Now, that the mean equals 2 is in the confidence interval. So remember, maybe let me draw a visual. The way we kind of relate a confidence interval, because it's not the relationship is not perfect, but it's pretty close. If this is 95%, then that means there's 5% left over, 2.5 left over about in the distribution to the left and to the right. And remember that when you're doing when you're conducting a significance test, you reject the null hypothesis when it's in, the extreme ends. So you reject the null hypothesis in this case if it was far over here where there's only 2.5% left, or so far to the right where there's only 2.5% to the right. Remember, the relationship is not perfect. It's pretty close though, because it's pretty close. And the reason they're not perfect is because they use different values of the sample proportion, or in this case, the mean, for the confidence interval. But that's a whole nother thing that we covered earlier that's a technicality thing. That's not really necessary here. So let's just go over what the answer would be. None. We cannot carry out the test without the original data. No, we can. That's not an answer. None. We cannot draw a conclusion at alpha 0.05 level because these two are wrong. C. Confidence intervals and significance tests are unrelated procedures. That is definitely wrong. We reject HO at the level alpha. No, we would not reject HO. We would fail to reject HO. And so the answer would be E. We would fail to reject HO again because we captured our population parameter in our interval. So we're going to fail to reject HO because it was not outside the interval, so it was not so extreme that it would occur less than 5% of the time.